In this video, we're going to talk about modeling quadratic functions. Recall the vertex form and standard form of a quadratic, because when we model these quadratic functions, it'll either be given to us in these formulas or we have to put them in these formulas. Either way, it's important to remember these two and what they give us. So now let's look at the quick sketch I've made of a parabola. We have an area where the parabola crosses the x-axis. These are my x-intercepts. We have a minimum here, which could also be a maximum based on the orientation of your parabola. These points are our vertex. And notice the x line that crosses through the vertex. Remember, that is my axis of symmetry, which I can find algebraically using the equation x equals opposite b over 2a. So in a parabola, we have roots, x-intercepts, zeros, solutions, all meaning the same thing. These two areas, or one area, or in some cases no area where the parabola crosses the x-axis. For our purposes in modeling quadratics, it's typically going to be one or two x-intercepts, and what it will be phrased as in the problem is asking you when an object will be breaking the surface or when it will hit the ground. The vertex is going to ask us for a maximum height or value, a minimum value, and we'll be asked to pretty much find the vertex. Typically the x-coordinate of that vertex is going to give us the time, which we can find by using the axis of symmetry formula. So if someone were, say, jumping or launching a rocket, we want to know the time it takes to get to the maximum height, this would be the x-coordinate of your vertex. Then we also have the y-coordinate of the vertex, which asks for the height or the value of a particular equation. So let's look at an example. Jason jumps off a cliff. His height can be modeled by the function h of t equals negative 16t squared plus 16t plus 480. How long until he reaches his maximum height? So in this situation, it is asking us for when, so the time it takes to reach his maximum height. And we would use the x-coordinate of our vertex here. The way that I would find the x-coordinate of my vertex would be to use the axis of symmetry. So in this situation, remember my function and I could find the axis of symmetry by opposite b over 2a. So opposite 16 over 2 times a negative 16, which would give me negative 16 over a negative 32, which simplifies to 1/2. And so our equation says that the height is modeled in t, time, and seconds. In this situation, it's asking us for how long until he reaches his maximum height, and that time is 1/2 seconds. So after 1/2 seconds, he reaches his maximum height. And so we used the x-coordinate of the vertex to find that. The next part, what was his highest point? Now it's asking what was his highest point. So this would be the y-coordinate of the vertex. And the way I would find that is taking this 1/2 and substituting it in everywhere I see a t in the original equation to find the h of t, or the y value of the vertex. And so negative 16 times a fourth plus 16 times a half plus 480. At this point I'm just simplifying, and I get negative 4 plus 8 plus 480, which would give me 484. And so this tells us that after 1/2 second, he reaches a height of 484. And so his highest height was 484 feet. The last part asks, when does he hit the water? And so if you remember back from the graph of the parabola, breaking the surface, hitting the ground, etc. are the x-intercepts, or my roots of my parabola. And so I'm going to try to find the roots, the x-intercepts, so that it will tell me the time it takes for him to hit the water, which we're assuming is at 0. So in this situation, you can solve doing the different methods we've learned, so quadratic formula, factoring, or complete the square. In this situation, my A coefficient is greater than 1. You could complete the square. What I would do is quadratic formula here. So opposite B Now I've gone ahead and put this all in quadratic formula. However, I want you to notice when you're doing this, we're going to eventually have to say 16 squared minus 4 times the negative 16 times 480, which is quite a bit. It's just large numbers to deal with. So look back in your original equation and look to see if you can factor out a GCF. In this case, I can factor out a negative 16. Which would leave me with t squared minus t minus 30. And I could easily go ahead and factor this. T minus 6, t plus 5, giving me roots at 6 and negative 5. So in the situation of these word problems, we have to now interpret our roots. And so we know that after he jumps, he's not going to have a negative time. And so after 6 seconds, he would hit the ground. The most important thing in solving quadratic functions word problems or modeling problems is to be able to identify what the problem is asking, think of it as a graph, and then use different methods we have established in class in order to solve those for those different parts.